chef set. To prepare a dish, example dosa sambar, idli chutney, rajma chawal, whatever. The chef has to finish 9 activities, some of which could be done simultaneously while others could not be done simultaneously. Okay, yes, we have some diagram to explain this. So from this what we can understand is there should be 9 activities performed in order to complete a dish. And out of those 9 activities, there are a few activities which can be done simultaneously, all at a time, but others cannot be done the same way. Right. One of the challenges faced by the chef was to precisely calculate the preparation time of a dish and communicate the waiting time to the customer. So, two parts. So, one is the chef is to calculate the preparation time, and next thing is he needs to communicate the waiting time to the customers. However, based on the past data, the chef had an idea about approximate time taken to complete each activity. He had noted down the best optimistic, worst pessimistic, and most likely, most commonly observed. So there are 3 cases it seems like. So time takens are taken in 3 different cases. So in best case, optimistic way, how much time it would take. Worst case, pessimistic, then how much time it would take. Then most likely, most common situation, there how much time it would take. So these 3 cases were recorded for all these 9 activities. Further, the chef realized that the frequency of the occurrences of most likely was 66.66%, and the frequency for occurrences of pessimistic and optimistic times were 16.66% each. That makes a total of 100%, right? So we'll clearly understand this last part. So we got 3 cases. So like we have the pessimistic case, the optimistic case. We'll start with optimistic way. Optimistic way, the pessimistic way, and the most likely way. So the percentage occurrences are going to be 16.66 and 16.66 for these two. So these much percentages, and for most likely it's going to be 66.66. So it's going to be like 66.66%. So if we want to express this as a fraction, it's not a big challenge for us. 16.66 is like this is 1/6. Pessimistic is again 1/6, and this is 66.66, 2/3. 2/3 is like 4/6. So 1/6, 1/6, 4/6 will make a whole of 1. So these are the chances of occurrences. Now we'll just go see about the activities in detail. Right. The diagram below shows the activities involved, and the table shows the optimistic, pessimistic, and most likely times for each activity. The time is indicated in the minutes. Okay, fine. Now first we have about the activities and which of these activities can be done simultaneously. We are getting that detail from this particular diagram. So it seems like out of these 9 activities which are named A, B, C, D, E, F, G, H, and I, we have got A should be done, A to be done alone, then B, D, F, G is done in this series, and C, E, H is done in this series, which means like these 4 activities and these 3 activities can be performed simultaneously, and we should finish with I. So that means technically telling, if I want to calculate the total time taken to finish or complete prepare a dish, it should be like time taken for A plus time taken for this or this, whichever thing is going to be the greatest or the longest time, that we have to take into account, plus time taken to finish I. So we'll have to take the longest or the maximum time between these 2 things, because like we are going to anyways perform all the 9 activities. In that case, we'll have to take the total time only by taking the maximum of this. So this or this, take these total timings and get the maximum of that. That comes into calculation, and A's time plus I's time. So this will give us the total time taken. What next? We are given a table that tells us each activity from A to I will take how much minutes it will take how much minutes, because it's mentioned like how much they are given the table in terms of the time term in terms of minutes. So it is telling us like in each of these cases, so how much minutes it will take. Fine. Okay. Now we'll take this info and we'll try to match it with the previous one. Yeah, we have this order given, right? So we'll just try to put this there. BDFG is going to be done in one series. CEH, this is going to be the other series. So we'll just note this because these are going to be happening simultaneously, that's why. So BDFG, CEH, right? Okay, I'll take this. BD, FG, CH on the other side. Okay, fine. Yes. Now we'll compare the time taken to finish the entire dish in all the three cases. Okay, first one, optimistic case. So A's time taken is 1 minute. Anyways, that should be taken into account. And also time taken for I to prepare this activity. I mean, to finish this activity, it's going to be 5 minutes. This should also be taken into account. Now I need to find out the total time of this plus this and this, and whichever is going to be the longest, the maximum time, that I should take into calculation. Okay, let's perform this. B, D, F, G. Okay, B, D, F and G, we have it here. So this is taking us 2 plus 5 plus 1 plus 5, right? So which means like it's 7 plus 1, 8, 13 minutes. Whereas C, E and H, I'll take the C, E and H. Yeah, okay. This is going to be like 10 plus 3 plus 9, which is going to be 12, 22 minutes. That means this part is going to be greater, right? Okay. In optimistic case, this is going to be greater. So I'll take that part into account because like this is lesser than the time taken here, which means my total time will be nothing but 1 plus these 3 plus 5, which is actually going to be what? This is already 22. 22 plus a 6 will make 28 minutes. So it will take the best way in best chance, or the optimistic case, it will take only 28 minutes to prepare this dish. Okay, we'll come to the next case, pessimistic case. Here again we'll have to do the same calculation. So I'll take B, D, F and G, right? Yeah, okay, B, D, F and G. So this will make a total of 3 plus 5, 8, 9, 19. And the other case is 13 plus 6 is, this itself is 19. Okay, fine. 19 plus, so 26 plus 6 is going to be 26 plus 6, it's going to be 32, right? Yes, 32 plus 6 is going to be, because 1 plus 5, we'll have to take those timings also. So that will make a total of 32 plus 6, 38 minutes. So worst case, it will take 38 minutes. And to the third case, we come here, we'll take the timings. It's going to be like 1, 3 plus 5, 8, 8 plus 1, 9, 9 plus 7 is going to be 16. On the other case, we'll have to take these three activities. This is 16, 16 plus 10, 26, 26 plus 6 is 32, 32 minutes. Because here again, CH time is going to be, I mean the time taken to complete these three activities is going to be greater. That's taking a longer time compared to the other three activities. So in all these three cases, this is not at all required because this is lesser than this time taken. So I'm taking only CH. Okay, fine. I believe like we are all comfortable with this, right? So time taken is going to be like 28 minutes in optimistic case, 38 minutes in pessimistic case, 32 minutes in the most likely case. Fine. Okay. And remember, we have got the percentages which we have written in fractions. So every 1 in a 6 case, this will happen. And here, every 1 in a 6, this will happen. And every 2/3 or 4/6 case, this will happen. Okay, all right. Now, clear with the sets. Now we'll attack the questions. Question number 1, we have the expected time to prepare the dish is the weighted average of the optimistic, pessimistic and the most likely time taken. So which of the following is the expected wait time for the chef to communicate to the customers? So it's clearly mentioned like the expected time is the weighted average for all the three cases. So which means it's going to be like 1/6 of whatever time taken in the optimistic case plus 1/6 of the same for pessimistic case and 4/6 of the most likely case. Now we are already ready with the time taken. 28, 38, 32 will correspondingly will just place these same three numbers here. So 28, 38 and 32. Okay, fine. Now we do this calculation, we'll get the answer. So it's going to be like 28 plus 38 plus 4 times of 32 whole divided by 6, common denominator. Yes, fine. So 28 plus 38 will make us 66. 4 times 32, 64, 128. Now this will add up to 4, 119. So 194. 194 by 6. The answer is 3s are 6 3s are 18. 4 2s are 32.9. balance is 2. So 2 6 or 1/3, 32.33 minutes. So my answer is 32.33 minutes. It's approximately 32.3. Option B is the right answer. Yeah, we are right. Option B is the right answer. Question number 2. Customer dissatisfaction is the difference of actual waiting time AWT and the expected waiting time EWT. So AWT is the actual time spent by the customer before being served the dish. EWT of the customer is the time communicated by the chef. What is the minimum waiting time? Minimum waiting time, that is EWT, that the chef should communicate to minimize the customer dissatisfaction. So very easy to address this question, this problem. So we are actually asked to find what should be the minimum waiting time. That is, if the chef or the waiter should communicate to the customer in order to minimize the dissatisfaction, so what time he should tell? This is obvious that the time that should minimize the customer dissatisfaction should be the worst time taken, which is going to be the pessimistic case. So pessimistic, in that sense, the answer is going to be 38 minutes. So 38 minutes would be the proper answer. So if the waiter is going to tell 38 minutes, which means the customer should be waiting for 38 minutes, which is the worst case. So there is going to be less chances for the customer to get dissatisfaction. In that sense, worst time 38 will be the right answer. Question number 3. Which of the following is the most volatile activity for the chef? Most volatile. What do I mean by that? So which activity will have so much changes going on in the time taken? So it will undergo sudden changes, so much of changes. So which among these activities is going to be such volatile activity? Fine. Yes. We'll come back. We'll test that. Going back to the table. Yeah, fine. So I'll clear off all these things. Yeah, fine. So we'll compare this activity wise. However, activity A or D and I. Okay, A, D and I. These cannot be the answers because there's no volatile nature happening in these activities. The time taken in all the cases are going to be same. No big changes. Okay, fine. They can be ignored. Fine. All right. Yes. Now what next? I'll check with the other cases. I mean the other activities. Okay. What about B? B, we have here to here. There is 2 minutes, 3 minutes. There's a 1 minute difference. That's a change. And 3 to 3, it's 0 minute change. So here 2 to 3, there's a 1 minute jump. 3 to 3, there's a 0 minute jump. So we are just recording the changes or the time differences between the cases. Okay, fine. What about C? Let's do for all these activities. C, this is 3 minutes, this is 1 minute. 3, 1. Though this is a -1 change, we'll take it as just 1. Okay, we just worry about only the change and we are not worried about in which direction happens, whether it is an increasing or decreasing. Fine, alright. Next, D, no, not in the list. E, it's going to be 3, 6, 4. This is 3, this is 2. Okay, 3, 2. Next is F. F is going to be, okay, F can again be ignored. All same. Okay. G and H. Okay, what about G? G is 5, 10, 7, right? So it's going to be 5 and 3. So this happens to have more changes than compared to all the previous. This is 1031, much lesser compared to activities G's time changes. Last H, 9, 13, 10. 9, 13, 10. This is 4 and this is 3, which is still lesser than G. So it seems like G is undergoing so much of changes when compared to different cases. So G is more volatile. So our answer, yeah, option C. G is the right answer. Yeah, yes, we are right. G is the answer.